Hello, I'm about to do a problem about alpha particle which opposes a gold nucleus with a speed of 1.5 into 10 to the power 7 meters per second. As shown in the figure, this is the alpha particle that's approaching the gold nucleus. And then the alpha particle is scattered at an angle of 49 degrees with a slower speed of 1.49 into 10 to the power 7 meters per second. So we want to find out in what direction does this gold particle recoil and in what speed. Now, we know according to the conservation of momentum, the initial momentum of the nucleus plus the alpha particle equals the final momentum of the nucleus plus the alpha particle, as shown by this equation right here, where Mn is the mass of the nucleus, V initial is the initial speed of the nucleus, and V final is the final speed of the nucleus. M alpha is the mass of the alpha particle, the initial alpha is the initial speed of the alpha particle, and the final alpha is the final speed of the alpha particle. Now we need to break these velocities into x's and y components. So V final alpha cosine theta is the x component of the alpha particle, V final cosine phi is the x component of the gold nucleus. Similarly, the y components are the sine theta for alpha particle and sine phi for the gold nucleus. Now we're going to do conservation of momentum in the x-axis. So in the x-axis, similarly, m alpha, v initial alpha plus m nucleus, v initial nucleus equals m alpha, v final alpha cosine of the theta plus mn v final cosine of phi. The initial equals 0.0 meters per second because initially the nucleus was not moving. Similarly, we're substituting the mass of alpha particle, which is 4 times u, and mass of the nucleus, which is the gold particle, 197 u. Initial speed of the alpha particle and mass, and then the initial, which is 49 degrees per theta. So we plug this into the equation that we mentioned earlier for the x component. And then when we solve for v final cosine of phi. Because we don't know phi, we don't know v final. So we get v final cosine of phi as 1.061 into 10 to the power 5 meters per second. Similarly, we apply the conservation of momentum principle for the alpha particle along y-axis. As we know, the alpha particle is not moving in the y-axis. Initially, both their speeds are zero, so the momentum becomes zero. Then, this is the final momentum of the alpha particle in the y direction. This is the final momentum of the nucleus, or the gold, in the y direction. Therefore, it has sine theta and sine phi. Similarly, we solve for v final alpha sine of phi. We get v final nucleus sine of phi as 2.283 into 10 to the power 5 meters per second. As we know, now we just found was v final cosine of phi, which was the x component of velocity, and v final sine of phi, which is the y component of velocity. So to get the magnitude, we do square root on the x component plus the y component. So we put in the values that we got for the velocities in x and y component and get a magnitude of this speed, which is 2.52 into 10 to the power 5 meters per second. Similarly, to get the direction of the alpha particle, we do tangent inverse of the y component over x component, y component being v final n sine of phi, and x component being v f n cosine of phi. We put in these values and we get 65.1. So the gold moves with a speed of 2.52 into 10 to the power meters per second at an angle of 65.1 after the collision. Thank you.